Ladies and gents, thanks for joining us. Today we've got Grant Stevens from Ravelin with us. And Ravelin like to call themselves as fighting fraudsters with data science. I actually pulled that from one of your co-workers, to be fair. So Grant's in the data science team, and he's going to talk to us today about a magnitude of things of who they work with, some of the data science aspects, some of the machine learning models that they've trained, and other bits and pieces. So stay tuned for the course of this one. Grant, do you want to say hello and give us a
Hi.
bit of an
Yeah.
intro to you?
Yeah, I'm sort of part of the data science team, but actually, we have a
Sort of
team.
part of it.
Yeah, we have a team called the data engineering team, which is sort of the
Cool.
go-between team between the data scientists and the engineers. So yeah, I'm technically a data engineer, which is a new term that we're still trying to figure out exactly what that is, but we'll just call it the go-between data science and the back end.
Cool. We'll call you Grant the Glue then.
Sure, that'll we can stick with that.
Tell us a little bit about you.
Yeah, so yeah, I've been at Ravelin close on 3 years now. Yeah, I came from sort of more of a data science background, and then at the previous role was more in the DevOps side, heavy backend, and so now I'm sort of balancing between the two. And yeah, so day to day is kind of making sure that the models are being trained properly, trained efficiently, that there's capacity for them to be trained and so on, but then also making sure that all the stuff that the data scientists are developing, the new features and stuff like that are being tied into the back end where they need to be tied in, and actually, I mean, eventually getting to better scores for all our clients.
Nice. Okay. I saw a ridiculous stat on your website. 53K models have been trained. You probably won't know that off by heart, but that's a ton of models that have been trained.
Yes, I mean, basically, we're training all all the time. We essentially train a new model for every client every 2 weeks, if not
Okay.
more often. It's
Wow.
very easy to kick off a complete new training for a model. There's sort of like a one line, basically just a button that you click that will start off a
Okay.
brand new training set that starts from absolutely scratch, gets all the new up to date data for that client, and trains the model, and actually goes all the way through to deploying it, not into live, but into a mode we call dark mode, that's sort of running it in parallel with the live one. It's kind of just so that you can monitor it before putting it into
Nice.
production.
Okay. And it's not necessarily like dark mode like Instagram. We'll get to it, but
Not
it's not
quite the same,
necessarily
no.
like that for people
No.
listening. We'll come to that.
Yeah.
Do you want to tell us a little bit about what Ravelin as a core do?
Yeah. So basically, what it comes down to is when you order your Deliveroo or sort of instant service, it's mainly the market, but yeah, there's a few others that we deal in.
Yeah.
And you put in your order, we'll get an API request from that customer, say a Deliveroo or a Glovo or somebody like that, and they'll say, "We have this person with, this is all the information we know about them. Should we allow this order to go through?" And we take all those details, generate a whole lot of
Yeah.
features, use some other information that we might have about those details that you've sent us, and we essentially send back a score and a prevent, review,
Hmm.
allow recommendation. So when your order doesn't go through and you have to enter in your credit card details again or something like that, that's often us, maybe, that's come back and say something's changed here, like your address has changed from the last time we've seen it, or
Okay.
the postcode that you're trying to send stuff to at the moment is super dodgy and stuff goes missing there. Maybe like make sure that this
Nice.
account hasn't been taken over or something like that. So in a sense, that's what it comes down to.
How many different data sets do you think you're looking at each request?
Um,
Appreciate that
that's
can
a
vary
tricky
as
one.
well.
So maybe a better way to answer that is, like, at the end of the day, when we're training models, we end up with
Mhm.
well over 1,000 features that are going into these models.
Wow.
yeah, there's a lot of stuff that goes into it. I mean, yeah, a lot of that also gets thrown away in the training process, but that's essentially something for the model to choose and throw away what it doesn't need and so on. But yeah, from a simple request that maybe has 10 fields on it, like your email
Okay,
address and your
fields.
account number and
Yeah.
stuff, we blow that up to, yeah, well over 1,000 features that we're looking at.
Okay. And just quite quickly, that generates a score, and
Yeah,
then end customer has a choice of, do we want to accept this payment?
yeah.
Yes or no?
Yeah. So I mean, they work with thresholds and all types of things to determine sort of where they want that limit to be, how many people they maybe want to let through, or how many get passed on to their fraud team to review, and how many get blocked outright, because they don't want their fraud team to be overrun with these sort of requests and stuff. Yeah, so it's up to them. We have a investigations team that sort of
Okay.
does a lot of hand holding with our clients that will sort of help them and say, look, this is, do all the analysis and stuff and come up with a number and say,
Yeah.
we recommend this. But at the end of the day, it's the client's choice.
Okay, cool. Do you want to give us an overview of what Ravelin do with machine learning, some of the databases that you use, rules engines? Do you want to break down those components and just help us understand how it comes together?
Sure. So I think the biggest thing in the background that drives most of what we do is all on Google Bigtable. I should have maybe said this before, like, because when this request comes in from a client, you're sitting there
Yeah.
looking at the little spinner on your screen, waiting for your payment to go through. We have to return as quickly as possible. So we generally,
Okay.
as a rule of thumb, trying to do well under 200 milliseconds response time,
Yeah.
which for us means we're actually aiming for more like 100 because of the network overheads and all those sort of
Yeah.
things.
Okay.
So that's why it essentially drove us to Bigtable, because there isn't something that can have that much data in it and return values sort of that quickly for that many requests coming in all the time. Mainly everything in Bigtable, and then we'd get a request. We'd get any other data that we need or have for that user or that client out of Bigtable, generate all the features, then pass it into the machine learning model, which are there's different models for different clients, which are run different architectures and different sort of platforms and stuff for that. Just depends on the client and what works better for them. There's not much more to it. There's a whole lot of storage stuff where we save a whole lot of the stuff in the background for in BigQuery, so that it's easier for us to analyze it later and so on. But in terms of real time, like get this thing back as quickly as possible, it's pretty much Bigtable and a lot of Go code.
How would you explain a rules engine to someone non-technical, by the way?
So yeah, so sometimes there's things that the model, let's say, for example, a Glovo is going into a new market and they want to open
Okay.
up in Antarctica, for argument's sake. Then our model's never seen orders from Antarctica, so we don't know
Mm.
how it's going to behave there, for example. So that's
Yep.
where you'd look at, say, okay, if the order's in Antarctica, maybe as a beginning, you sort of know that all the clients there are trustworthy people, because only trustworthy people would go to Antarctica, and you just allow everything from Antarctica.
Okay.
So the rules engine sort of comes in and saying, okay, if the order location is Antarctica, override the score and just make it allow. But it obviously gets a lot more complex than that quite quickly, because you can say, well, add a couple of points to the score, or
Okay.
there's all types of combinations of things that you can do to the score with the rules engine on top of the machine learning predictions.
Okay. I understand that. I understand that. Help me understand this relationship then between you, let's just call you Grant the Glue, engineering, data engineering, and data science.
Yeah.
I'm hearing some quite complex engineering challenges. You're talking about network overheads, performance. There's obviously latency you need to think about between the transactions. So, just give us a high level overview of what engineering takes place at Ravelin.
Yeah, sure. So I guess everybody has their own things that they're optimizing for. So
Yeah.
from a data science point of view, if if they had their way, they'd be running absolutely huge models that would come back with like 10-second prediction times, but they'd be deadly accurate. And from the
Okay.
back end point of view, we might be optimizing for like, we want to return in 10 milliseconds every single time.
Yeah.
And so in a way, I always think of the data engineering part of that is sort of saying, okay, we're trying to balance those two in a way and saying, well, we can get very good performance with like 100 millisecond response time. We're getting to the point now where some clients might say, we don't care how long you take because that's not our model to return as quickly as possible.
Okay.
So, you can run a more expensive model for us. And that obviously is a whole other discussion. But yeah, so there's basically looking at the back end team who's looking at everything up to and after the machine learning prediction. And then there's the data science team, which is looking after the models and stuff. But what is quite interesting too is that the data scientists also end up having to develop a couple of features themselves, sometimes in the beginning phases, just querying them out of BigQuery or something. But then there's not always, might not always have time in the backend team to be doing it. So the data scientists end up actually implementing the features themselves in the Go code. So everybody kind of spans a few different areas. If they determine that this feature is really worthwhile and there's nobody to implement it, then they'll jump in and do it themselves, which is quite nice.
To my ears, it sounds like you're the referee between speed and accuracy. That's my own analogy, by the way, that I've kind of just thought of.
Yeah, I think that's a good way of putting it. I think it's obviously, I mean, it's not like the data scientists would ever expect us to run a model that's going to take 10 seconds to predict or something like that. But we had a case recently where somebody trained a model that was sort of, I think it ended up being 3 or 4 gigs big. So scaling this thing up and down was a bit of a challenge. And then the prediction times were sort of just on the edge, but it actually got even worse than that because the data that this thing required was also a whole lot bigger than any other model. So then the network overhead's higher. And so you keep on this sort of this snowball effect of like, okay, the model on its own maybe predicts quickly enough, but all the other sort of upstream things for that model just make it unfeasible, unfortunately. But
All right.
you learn things from that, and so we've got a stripped down version of that we're busy working on at the moment that sort of takes the ideas of that and tries and does it a bit more in parallel and stuff like that. But then there's a lot more back-end changes and stuff that we need to do to get that working.
Okay. I'm trying to take like a holistic view here. Google Big Table is obviously quite prevalent. Give us an understanding of a little bit more tech that comes into play.
Yeah, it's actually quite nice in that it's relatively simple in that.
Okay.
So we run all on Google Cloud, and we have a Kubernetes cluster and Bigtable. There's obviously a couple of little, I wouldn't call them ancillary things for caches, a bit of Redis and things like that. The main gist of it is that there's a Kubernetes cluster. I should also say we're now on about five or six Kubernetes clusters, but they're completely separate. There's 1 or 2 in different regions, just sort of doing the same thing. Then there's different ones completely for training models and so on. So we keep those 2 separate from live infrastructure because we never want like a training operation to actually influence anything going on in the live cluster. So yeah, it'll come in, hit the cluster, hit Bigtable a couple of times for different bits and pieces as it goes through, hit the machine learning model, which is also all running in Google in the Kubernetes cluster. We've looked at different options there, but because of the time requirements, it's very tricky to actually go and call out to, I think Google's calling it Vertex AI or whatever their machine learning platform is at the moment. And so it's very difficult to go out, call something to them and come back because that immediately adds a bit of extra overhead. Whereas if it's all in the same Kubernetes cluster, you're kind of bouncing around quickly within yourself.
Nice.
And Bigtable is fast enough to be able to do that once or twice. Yeah.
All right, nice. Help us understand a little bit about that collaboration then between teams, because it seems as if it's well oiled. Help us understand that collaboration and what gets complex.
Yeah. So it was quite nice actually at the beginning of this year. I joined the data science team sort of full time for 3 or 4 months. to make that sort of collaboration easier and for us to understand more about what's going on in that team and how they work, so that there's a better understanding between the two teams. So firstly, just being able to do that is great, because you you get a much better view of what's going on in the team when you're joining their stand-ups and sort of
100%.
following along and actually doing some of their sort of tasks that normally they would do. You end up doing and seeing, oh, this is a real pain point and we could solve that easily, whereas they just used to dealing with it or whatever. Essentially, the data science team is trying to come up with new and better models all the time. So they'll be investigating new features, investigating new model types, trying all of these, and actually sometimes even going as far as deploying these models in a dark mode, which we'll still get to, to evaluate how well they perform and so on, and if they're fast enough and all the rest of it. And then they'll come to us and say, look, we have this new type of model. It's amazing. It's whatever, 30% better than the last model, but it's going to need this new feature that's really hard to get. And that's where we'll go in and say, okay, actually, you might have done that with a complex query to get the data out, but we need a separate service. So it's all, it's all microservices. I think we're over 100 microservices at this stage.
Okay.
And then we'd say, okay, we need a dedicated service that's just going to calculate this one feature. And then generally we'll go in and write that one service to kind of generate that one feature for them. And so that's unfortunately slightly slow, because you might have this feature and this new model, but like obviously writing a whole new service for a new model might take a bit of time. Then pretty much keep on going like that.
We're on a good path. Let's go into dark mode here.
Okay.
Let's talk a little bit about training models.
Yes.
Because you make some really nice references there about taking some of those models into production, seeing what works, understanding what engineering need to do. And some of that might happen in dark mode. So it'd be really good, I think, to touch on that and see what dark mode means to you. People probably obviously understand what you're going to say with that reference, but let's just explore it a little bit more.
Yeah. We'll start with the training maybe. So, I mean, let's say for argument's sake, we call it an extraction, and every 2 weeks there's an auto extraction starts. It'll spin up a new instance, a new Kubernetes pod, which inevitably is a new instance because they use quite a bit of memory and stuff, and it's all auto scaled and all of that cool stuff. And it also scales. Different clients need different amounts of memory and CPU to actually train a model within a certain amount of time. So all of that sort of is taken into account. So a new machine will get spun up to train this model. It goes off and fetches all the data it needs. So obviously part of the model training is that you need the same data that you would have gotten in live to train the model. And our data science part of stuff is all written in Python. So what we've actually done is we've got all the Go code that generates features in live is available as a separate binary that can generate the features offline too, so that you never have a mismatch between your online and offline features, because otherwise you're training a model that's based on features that aren't actually the same as what they are in live. So the Python actually calls a whole lot of Go binaries to go and calculate all these features. It does its training, and depending on the model type, this can involve some TensorFlow or some scikit-learn or whatever it is, also completely customizable per the client. And obviously there's parameters for clients and how much data and all that sort of stuff to use for them. And the final step of it is sort of generating. We have 2 services in the main architecture. We call it core. That's justice and jury. So justice is the thing that sits on the core side, and justice is getting a score. So a score request will come in. Justice will say, okay, which jury do I go to get the score? And jury is essentially the thing that contains the model. So the justice will go to a jury, and jury, based on the model type and everything, will generate a score for that justice. So the final step of the training process is actually generating a new jury image, and the jury image contains everything that's needed to generate a score for that client.
Is there a guilty and non-guilty?
So we just call it prevent and allow. We just have prevent and allow. unfortunately, guilty, not guilty. We don't want to presume people are guilty at this stage yet.
Fine.
They might have
Okay.
just put a wrong number in. Okay, so you have the jury image that the model
Yep.
training gets to. It generates this jury image. And then the final step is actually putting that jury image into a thing that we call dark mode. And essentially what dark mode is it's a thing that runs in parallel with the live model. So you have live models and you have dark mode models. And it will be generating scores using the new model, but not sending them back to the client and just saving them to disk or to the database. So what that allows you to do is you can have a live model and a dark mode model running in parallel next to each other, generating scores for the exact same requests. And then comparing them at the end of the day is really easy. So you can get a really nice distribution saying, this is the distribution for the old model, this is the distribution for the new model. They're pretty much identical. Or this one has there's all types of things that you can, analysis that you can do on the results that these things return. And now we can go and say, take the dark mode model and make it live and remove the old live model. And what we've built as part of this is you can actually have multiple dark mode models running at the same time. So for one request, you could be getting 7 or 8 or 10 scores. And so you can compare all types of different models, sort of seeing different, how they react to different requests and so on. I should also just say, as part of the training process, there's also a reporting step, and we generate about 5 or 6 different reports of model performance at that time of training. But that's obviously not of the data that's coming in at the moment. So you can always sort of look at the live data of what that model is doing, but then also look at the model report and say, on the data that it trained on, these are the results.
Treat me as dim. So if we have a data science team listening, what is the point that you think you should start to introduce dark mode? Or do you think it is more, let's just say, use case specific? Maybe as in it works for Ravelin because the space that you're in? Or is this a good data science standard that you think people should adopt?
What it's come down to is we've just made it easy. So I think if everybody should run some sort of dark mode in some way before they deploy a new model, because you've got to compare what your new model is doing compared to your old model, because otherwise you get these big step changes in behavior and your users are going to go, what happened here? And you'll be like, oh, we deployed a new model. And they're like, but I don't want my, my data can't change with a huge step like that overnight because you deployed a new model. By having this dark mode thing, it just makes it a whole lot easier to go and do this analysis sort of in real time, rather than having to download the last week's worth of requests, run them through my model manually, sort of thing. What we've also found is that it's because so there's justice, and the thing that runs the dark mode model is called ancillary justice, and it actually shares 99% of the code of the justice service. And so it's really easy to actually do. The output is just to a database instead of to the thing. The rest of the scoring steps is sort of, so yeah, I would, the first time that I've sort of worked with something like this, but yeah, I don't think I could ever go back to anything else, just because it's, if your predictions are actually being used in any sort of real world use case, you do not want those changing suddenly overnight, and you need an easy way of evaluating them.
I understand now. So ancillary justice basically is just a replica of the code base, or 99% of the code base that you've already built. And you would just go in dark mode in essence and look at the new models. Right. Okay. So I was thinking you actually might have to not necessarily build something entirely from scratch, but you could start introducing it from, let's say, the next 2 weeks if someone is listening.
Yeah. It's, as I say, I was. It's actually when ancillary justice starts up, it gets one extra Boolean value that says, is dark mode yes or no, and the rest of it is all the same justice code. It's really that simple.
Love it. Okay. You make a good point about it's customizable for each individual client, and some of your models are bespoke for each client. that
I
you
think
work
we're nearly
with?
on everybody has a bespoke model. Essentially, what happens is when a client joins, depends how much you want to go into payments and stuff, but chargebacks
Yeah, yeah.
nearly take about 3 months to come in, and chargebacks is
Okay,
the best sort of signal of fraud on these things. So generally, we
okay.
need about 3 months worth of data from a client before we can train a specific model for them, because you need that very clear signal that this is actually fraud. But generally, as soon as we've got 3 months to get a bespoke model, we have what we call a generic fallback model, which everybody will go
Yeah.
on when they join us. But generally, yeah, after those 3 months have passed, we can get a much better model to the client pretty quickly. And yeah, then keep
Okay.
on improving it after that, obviously.
Nice. Okay. So what I hear is essentially you replicate what's already been built.
What ends up happening is that each data scientist will get assigned to a client. And
Okay.
so their job is to specifically look at that client's data, because we span quite a few different verticals in clients and stuff. The
Yeah.
data can be vastly different between them, and different model types work better on different clients. The one that we're sort of looking at the moment is heavily dependent on item descriptions that you're buying. And
Okay.
so random keywords in that item description just end up being very fraudy. So
Okay.
you sort of that sort of thing is only particular to that kind of client that has these sort of, whereas a Deliveroo burger and chips is not necessarily fraudy. There's there's some things where you can say, well, that's definitely a more fraudy item. And so yeah, a model type will generally be better for a specific vertical in a client, or a
Okay.
specific vertical that a client operates in.
This is slightly away from tech, but so as data scientists, you're looking at the data. Are you seeing quite a lot of trends that fraudsters are adopting when looking to conduct fraud? Like, do you have an opinion on what you're seeing?
Yeah, I think the investigations team specifically picks up on quite a few of these trends quite quickly.
Okay.
And you sort of pick up on some strange things. At one stage, I mean, this was many years ago, there was just a lot of sort of on demand taxi fraud around
I was just about to say
Luton
ghost
Airport.
rides.
No,
Okay.
no, they were real rides, but they were using fake cards, if I remember correctly. I can't remember the exact details, but
Okay.
it was all happening around Luton Airport for some reason. And so
Hmm.
the model actually, after it's seen that data for a while, sort of picks up that all the postcodes in the Luton area are fraudy, which is
Oh, did
a bit
it?
tricky. Yeah, which is good and
Okay.
bad, because you are picking up
Sorry
all of
to our
these
Luton
things.
listeners, by the
Yes,
way.
that's exactly the problem, is that everybody in Luton is now considered a fraudster because of, a couple of bad actors. So it can be a bit sort of broad like that, but it is able to pick up on some of these things. And so in the dashboard that we have for our clients, there's a heat map of sort of where fraud is taking place. And yes, some of the obvious ones are obviously on campuses. There's a lot more fraud taking place than just off campus and stuff like that. So there's definitely trends like this that you pick up, and probably a lot faster than anybody else is, because we sort of have a bit more of an aggregated view of some of these things.
Yeah, okay. How many countries are you in? Do you know
I
off the top of your head?
don't. We have
Let me have a quick look.
we have
Countries
clients
on the
in a
website.
lot of countries.
Okay.
Yeah, I don't actually
Countries
know
we
what the
serve
exact.
clients in 185.
Okay, there we go.
Wow. Okay. That adds to the complexity as well. I
Yes.
can
So
imagine with localization, things like that. I'm just thinking off the top of my head.
yeah, so there's luckily that's why the sort of machine learning AI approach to it is so good, because one of the inputs to the model will be, what market is this order in? So is it coming from, is it well, there's a couple of different things, but one of the very obvious other things that get is the order's been placed in Mexico, for example, but the credit card
Yeah.
is from the UK. And so
Okay.
you're sort of immediately going, okay, there's a mismatch there. Like, it might not be obviously fraud, but the score is definitely going to be higher, kind of thing.
Yeah.
But anyway, so the point I was making is that because the market is an input to a lot of these models, you'll you immediately, the model almost has a switch that says, okay, this is in Mexico, therefore the fraud is higher or lower depending on what is going on in that country.
Gotcha. What's to come from you guys and girls over the next 12 months or so? What's to come in engineering? What's to come in fraud and investigations, do you think? Or what's the noise that's going on in the business at the moment?
There's a lot of stuff going on with the PSD2. It's sort of,
Okay.
you might have noticed when you're trying to pay for stuff recently, you get redirected a lot more often to enter the code from your bank or something like that.
Payment
Um,
protocol?
PSD, I can't remember the acronyms now. That's not my strong
Okay.
payments. Anyway, there's quite a
Yeah.
nice map on our website that actually it says which countries are adopting it. There's a whole new
Okay.
spec that the EU came out with. So that's one of the things that we're trying to simplify by having a product that's trying to not send. So there's a huge drop off in people that are paying for stuff when they get redirected to a page like that. So
Yeah.
we're applying the same sort of machine learning type stuff to that, sort of saying, do we need to? Because if what it comes down to is if the retailer doesn't redirect you to the bank thing, then they end up having to pay the cost if the payment doesn't, if there's a chargeback on the payment. Whereas if they
Right.
do send you to the bank thing, then it's on the bank. So we're
Okay.
trying to make predictions there, sort of saying, we don't think you need to send this over to verification because like
Gotcha.
it'll go through. So that's one of the big things. The other thing in terms of models and stuff is we're going more into sort of, I'm going to say, deeper learning. So looking specifically at which we've sort of done words and fraudy words, but now we're starting to look at whole sentences and stuff.
Mm.
But it's an interesting one because analyzing a whole sentence is obviously a lot slower than analyzing just a couple of words, and we're
Yeah.
starting to, you have to make more and more trade-offs in terms of time versus
It's
complexity of the model.
contextualizing it, isn't it? Really, I guess.
Contextualizing, like for example, one we've seen is sort of an iPhone. Somebody selling an iPhone on its own is generally not as fraudy, but iPhone cases are particularly fraudy. So knowing that like the description is going to contain iPhone isn't necessarily the strongest sort of signal, but iPhone case is a lot stronger kind of thing, and contextualizing that, yeah. So NLP models and stuff like that coming into that.
Okay. You're hiring, I think,
Yes.
for a lot of people listening who will be genuinely quite interested. I think you've given us, a really fab breakdown of what engineering looks like at Ravlin and what sort of challenges you'll cover across both engineering all the way through to data science. So, what people or skills are you looking for, do you think, across the spectrum?
That's what's been one of the best parts about working at Ravelin is that there are just some exceptionally smart people, and
Okay.
smart in such a way that they're not sort of shoving it in your face every day, sort of telling you, look how smart I am, I figured this out. But it's a
Yeah.
real sort of team collaborative effort in doing these things, and we solve this problem
Good.
together. That coupled with like this inquisitive nature of sort of, why is this happening? Why is this particular postcode fraudy? Or, why are we seeing this weird behavior? And that the model sometimes takes twice as long to predict than other times and stuff like that. I think those two things together, sort of, that's the type of people that we have, and obviously looking for more people like that. Um,
Okay.
and yeah,
Curiosity and
yeah,
smarts.
curiosity and smarts. But I think, yeah, this it's I guess the smarts is sort of almost secondary to just being the nice people,
Yeah.
because there's a lot of smart people that can be very abrasive about it. Maybe maybe not quite the right way of saying it, but I think you know what I mean.
Yeah.
And
I get
yeah,
what you mean.
it's that combination that just makes it a pleasure to work there. And yeah.
Okay. Good. Any skills, as in straightforward skills that the company or teams optimize for? Let's just say Go or a particular stack. Or are you quite agnostic?
So Go obviously helps a lot. When I joined, I hadn't actually done, I'd sort of done a bit of Go in my spare time, but hadn't sort of done it as a job ever, and sort of had to, was a bit slow in the beginning, and everybody helped out and got going like that. But Go is a big plus. I think other than that, it's also a bit of it's not a normal job in that you sort of just I don't know, selling widgets or something. You're actually stopping some legitimately bad people from hacking into people's accounts or or
Yeah.
stealing lots of money and stuff like that. So it's a slightly different mindset like that, where you're looking at things going, hey, I actually stopped this person's account being taken over today, which is quite
Yeah,
a nice
great.
feeling to, I would say, go home to at the end of the day. But since we're mostly at home, stay at home with for the rest of the day.
Good. Good. I want to say big thanks. I think it's been, marvelous you coming on here, talking a little bit about what you're doing and what you're building, and just a really solid breakdown of that as well. For someone whose, technical knowledge is quite shallow, I think I could really contextualize what you were doing. So that was really, really useful. And, I think I speak on behalf of everyone listening as well.
Thank you
And
very
thanks
much.
for helping us as well,
Oh no.
fighting fraudsters. You're helping
Yeah.
everyone listen.
No, no, thank you for having me. It's been a real pleasure, and yeah, I hope it's sort of one of those things that when you're working with it every day, you don't necessarily know what's interesting to people anymore. And yeah, so I hope that was interesting and understandable.
It was. For everyone listening, there's a lot more links below in regards to Ravelin website, Grant's LinkedIn profile, links to some of their funding, careers, etc. So check that out. If everyone can like, share, subscribe, show your friends what these guys and girls are doing and building. They're in essence helping everyone. So get these guys and girls out to the world. And again, Grant, a massive, massive thanks. And we'll see you all soon. Thanks a lot. Hey guys, thanks for watching this episode. Massively appreciate you listening and checking in with us. If you want to find out more about us and what we're doing, please check us out on social media. What we're trying to do at Enginears is build a community to drive knowledge sharing and experiences. On Twitter, we can be found Enginears.io. It's no underscore. We've also got a website, which is enginears.io. These links will all be posted in the description. Any feedback and comments are massively appreciated. We're always looking to improve on where we can. Thanks, guys.